Hello and welcome. We have today another tree question asked by Facebook, Microsoft, and Google. It's called increasing orders search tree, right? So, given a root of a binary search tree, rearrange the tree in order so that the leftmost node in the tree is now the root of the tree, and every node has no left child and only a right child. So the description might not be the best, but the diagrams are, I'll say, the best, right? So you can see we have a binary search tree, and we're supposed to convert this to this, right? So basically, it looks like a linked list, right? You have node one being the root, two, three, four, five, six, seven, eight, nine. And if I read this order for you out, right, you know it's in ascending order, right? So essentially, we converted our binary search tree into a kind of linked list, but more like a tree with only right children, right? So only with right children, and every node is sorted according to their value in sorted order. So how do we convert a binary tree into a list like this, and then we join stuff like that? Well, basically, with a binary search tree, if we do an in order traversal, right, where in order traversal is like we go to the left nodes first, the middle node, which is the root, right, and then to the right node, right, then we'll have everything in sorted order. Because the property of the binary search tree is that every element on the left of a root is less than the root, and every element on the right is what greater than the root. So if you take care of the elements on the left first, come to the root, and then come to the right, right, it will be in sorted order, right? So and natural reversal is all we need, and you can see this is a smaller example of 1, 5, and 7, right? From this binary search tree where you have 5 as a root. So the idea of what we want to do is to first, have a binary tree, get every element in the tree, right? Like, probably put it in a list, and then from our list we'll generate a new tree and then return that. So um, I want to call that list. I want to call it the list that will be storing our stuff in, right? Now our base case will be that if our root is equal to null, right, then we just want to return null, right? That means if our root is empty, return null. Then we create our list, and then um, we want to call a function to what get nodes. So get nodes will take what the root and a list, and then after getting the nodes, what we want to do is now that we have the nodes in sorted order, right? What we want to do is what um, create a new tree with only right children, right? So before that, I just want to go through the avoid method of what getting the nodes, and that will be take arguments tree node, and then we take also our list, right? So we have a list of integers basically, right? So if our root is equal to null, right, then it's terminating. So what we want to do is to return. Else, what we want to do is first, because we are working on the listen the so it's get to nodes, because we are working first on the left side of the tree, right? We want to do root dot left and then list, right? And then we want to work on the actual root. So then we'll say that list dot add or to root dot file. We're adding the value to our list, and then again get nodes. So get nodes, root dot right, and then the left. So basically, it will be adding the nodes to our list. Start first with the left subtree, take the root itself, and then go to the right subtree, right, and do that. So in the end, it just returns. So we'll have our list filled up with the stuff that we need, and then now we can create what a new tree node, and I want to call it result, right? So our result is going to take the first element in our list basically. So let's not get 0, right, as its value, and then we want another node that's pointing to result, which is what we return. So I want to call it the head, call it set it to result, and then we want to return head, right? But only after we've done a certain bit of processing. So our processing is going to be that from the first element onwards, and beyond, right? In the tree, what we want to do um, is to make sure that everyone becomes what a right child of his parent, right? So k is less than there's a size and k plus plus, right? So basically, I would say that result dot right is equal to what our new tree node, and I'll give it the value of what list dot get key, right? And after giving the value of list dot get key, I'll just say result is equal to result dot right. Like it moves to the next. Basically, it's like a linked list, right? It moves to the next node. So initially, I'll create the result we're pointing to one, and then we go to a new node, and then it points to two. So that is initially it's going to be what two is going to be result dot right basically, and then we say result is now equal to result dot right. So now it's pointing to two, and then we keep adding and keep adding and adding. But the original pointer, which is the head, is still at the head of the root, right? Or the original root is one. So eventually, when we return head, it's going to return the tree that we design. So just run this. It cannot find left. It's supposed to be list. Sorry. And so passes the first few test cases, and it passes everything, right? So 100%. This is an O of n solution, right? You have to touch each and every single node. I hope this has been helpful, guys. If you like, leave a like, and I'll see you guys on the next one. Peace.